Alright, so today I'm going to be talking about synthetic division. The purpose of synthetic division is to find zeros of polynomials. So the example problem we have today is x squared plus 5x plus 6 divisible by x plus 3? So essentially what this problem is asking is whether x equals negative 3 is a root of x squared plus 5x plus 6. Now, we know that this root is x equals negative 3 because, if we set this up as an equation, y equals x plus 3, and we plug in negative 3 for x, we get y equals 0. We call y equals 0, or the places where it intercepts the x-axis, we call those the roots of a function. So, to get 0, it has to be the opposite sign of the number, right? So, that's how we know that the root is going to be negative. So, we apply that same idea in synthetic division. So, we started off with just this little L-shaped thing, and since our root is negative 3, we put this here. The way I like to think of it is that you're going to want to write the equation, or the function you're dividing let me reword this in my head, the function that you're dividing this function by in terms of x minus a number. Now when you have x plus 3, you're going to have to rewrite that as x minus negative number. You know that the negatives combine to form a plus, so these two are the same thing, but you have to have that negative number, right? Okay, so now that we know all of that, the first thing we're going to do is we're going to take the coefficients of these three and we're going to put them in our L. So 1, 5, and 6. If we had more terms in this function, we would just keep adding it. But since there's only 6 terms, we only have 3 coefficients. Right. So then we take this first number and we put it down here. Then what we do is we take this number and we multiply it by negative 3. So 1 times negative 3 is negative 3. Now what we do is we add these two numbers. So 5 plus negative 3 is 2. 2 times negative 3 is negative 6. Negative 6 plus 6 is 0. So, if you get a 0 as your final number, you know that it is divisible by x plus 3. How do we know that? So this number represents the remainder. So suppose our remainder wasn't 0. Suppose our remainder was 1. If our remainder isn't 0, we can't say it's divisible by this function. Because if there's a remainder, we would have to write it as 1 over x plus 3. Plus this stuff, which I'll get to later. That means it doesn't divide equally. And what we're looking for here is that it divides equally, right? Let's change this back to 0. Alright, now let's talk about what these two numbers represent. These are the coefficients of the function that when you multiply with x plus 3, you get this. So, we know that our first is just going to be x. So 1x plus 2. Now, I should mention this. How do we know that our first exponent is just to the first power? Here's how I know. I normally just subtract 1 from the highest exponent. But how else do I know that? I know that if you multiply x plus 2 times x plus 3, you're going to end up with an x squared. If this was x squared instead of x to the first power, you would end up with x cubed, and you don't see x cubed in here. So this is definitely x plus x to the first power. So now we can double check to make sure that x squared plus 5x plus 6 really is divisible by x plus 3. So what we do is we set up this little box, x plus 3. So we get x squared, 3x, 2x, 6. Basically what you do is you just multiply this by this, and this by this, this by this, and this by that. And we end up getting x squared plus 5x plus 6. This matches that, so we can firmly say that x squared plus 5x plus 6 is divisible by x plus 3. Now, another way to find zeros of polynomials is using long division. I don't have a video on long division yet, but I might have one in the next couple days, couple weeks, I don't know. If I do, I'll put a video link here somewhere. That's how you use synthetic division to find zeros of polynomials.